All right, good people. Today is Wednesday the 21st. All right. The agenda is on the board. We've already done our warm up. I've checked our homework. We do have questions about the some of the word problems. So tomorrow I'm going to go over that. Go over your homework questions. So if you have questions about the homework, tomorrow I'll go over it. We don't have a warm up tomorrow, so I'll make sure to go over your questions about your homework tomorrow. Um, Today, we are going to finish out our group work that we started yesterday on justifying properties, justifying steps in equations. We have to finish that. After which, we're going to go over some other properties um, and put those things in our notebook, like some definitions. We're going to just go over that. And then you have another group assignment that you're going to do. If we have time, I'll start talking about solving inequalities, which is very similar to solving equations. All right, and so we'll practice that if we have time. If not, then that'll go into tomorrow's agenda. Questions, comments, or concerns? Okay. All right, so far we've answered essential question 1. We're still working on 2. We have answered part of 3. These things right here we should know. We'll hope to get to inequalities and literal equations tomorrow. Okay? All right. No pressure if we don't. All right. Warm up. Are there any that you need me to go over? Are there any that you need me to do? Maya? 5? 5. Okay. All right. So number 5, first things first. You cannot get B by itself until you remove the denominator. This is division. What's the opposite of division? So we're going to multiply both sides by -3. Okay. Out to the side, let's look at this. If we have B plus 50 on the top divided by -3, when you multiply, let me do this at the bottom because I don't have enough space. When you multiply by -3, that's the same as multiplying, look, just like this. You can cancel out diagonally, okay? You can cancel out diagonally. So that's just going to leave you with B plus 50, okay? Even if you were to multiply, when you divide, if you leave it as B plus 50, and you multiply the top by 3, and this is 3 on the bottom, look, this is going to cancel out anyway, because -3 divided by -3 is going to give you B plus 50. Okay? All right. So either way, on this side, we're left with B plus 50. I just wanted you to understand that logic. Any questions about how I get B plus 50 on the other side? If you have a question, please let me know. Okay? So now we're going to multiply 95. Okay? So we got 95 times a -3. What's 95 times a -3? -285. Good job, baby. So now what are we going to do to isolate the variable B? Subtract 50. Very good, sweetie. So we're going to subtract 50 on both sides. This is gone and I'm left with B is equal to, all right, and what does that give me on the other side? What is -285 minus 50? Negative what? Say again? No. How'd you do that? You're subtracting. You got -285 minus 50. -335. Okay. Got it? All right. Any other ones? Yes, baby. 6. All right. So to solve for C, this is a C here, okay? Is that C or E, y'all? C. Okay. All right. Let me make that darker so I can see it. So to solve for, I meant to put my glasses right here. I really did. I need to go get them. All right, so in order to solve for C, we must move what first? What do we move first? Do you know, baby? 40. How do you move that positive 40? Mm-hmm. Very good. You're going to subtract 40 from both sides. Good job. This is gone, and we're left with negative C over 3 is equal to, what is 23 minus 40? Yes, ma'am. Say it one more time. Negative 17. Okay, so now we got to get rid of the negative and we got to get rid of the 3 that's on the bottom. That's division, right? How do we get rid of negative and the 3? Anybody know? You multiply by 3. I can multiply by what kind of 3 though? Negative 3 to get rid of the negative as well. You don't have to make it into 2 separate steps, okay? So we're going to multiply both sides by negative 3. That's this negative times a negative is going to make it a positive, correct? Okay, and then when you divide by 3, that's going to get rid of the 3 there. So you're left with positive C is equal to what? Any questions? All right, any other questions, folks? Yes, baby? Say it one more time. Number 3. Okay, did I say that right, Michaela? Is that the one? Okay. All right, so how do you get W by itself? What are we going to do here to get W by itself? Yes, baby. What are we adding? What's on the same side as W? 19. What kind of 19 is it? Okay, so how do we remove a positive 19? We're going to subtract it. Does that make sense, Neri? Good job, baby. So now we have 53. We got minus the 19. What does that give you? What's 53 minus 19? Come on, y'all. You should count. 34. This is gone and we're left with negative W. Now how do we get W by itself? What do? What is the coefficient in front of W? What kind of 1? Negative 1. So if you want to rewrite this as negative 1, that's fine. So now how do we remove the negative 1? How do we get rid of the negative? Not subtract. What operation is divide? Okay, why do you think we're dividing instead of adding or subtracting? What operation is between a coefficient and a variable? Multiplication. So the opposite of multiplication is what? Division. You got it now, baby? Good deal. So what's 34 divided by a negative 1? So W here is equal to a negative what? 34. Okay, Michaela, we good, babe? Okay. Any other questions? Yes, baby? Number 4. All right. Now we need to get N by itself. Okay. So what are we going to do first to get N by itself? Nicholas, what do we do first to get N by itself? Okay. So what's on the same side as the N? You got 2 over 7. You said that. What else is over there with N? You have to subtract 8 on both sides. Okay. You got it. So this is gone. Okay. And then we have 2 over 7 N. And now we got 2 minus 8. What's 2 minus 8, y'all? Okay. All right. So now, what are we going to do to get N by itself? How do we remove 2 over 7? 2 over 7 is being multiplied, right? What's the opposite of multiplication? But when we divide a fraction, what are we essentially doing when you divide a fraction? How, though? How do you simplify? If I'm dividing a fraction, how do I do that? Let's do 2 fractions. Let's do 1/2, and let's divide 1/2 by another fraction. What's another fraction? Give me one. Come on, y'all. 3/4, somebody said. How do we do that? How do we do that? Okay. How though? The acronyms, remember I told you, are to help you remember the actual rule, but it's not the answer. In your mind, you need to be thinking, what does this acronym mean? That's going to be the answer. Okay. So essentially, because no point in remembering an acronym if you really don't know what that essentially is doing. You can't explain it. I want you to be able to step away from that and actually explain what that means versus just giving me the acronym to help you remember. Okay. So, what does that acronym mean? What is that saying? You said keep something, something. I don't teach acronyms, so I don't really know. Thank you. So, the first fraction stays the same. We're going to change the division sign, you said, to what? Sounds like a mathematician. Now, what are we going to do? And what is the flipping called? Reciprocal. Good job, Allie. What's the reciprocal of 3 over 4? 4 over 3. Okay, so now what are we doing? Multiply straight across. So this is the same process. If I'm saying I'm going to divide that fraction, essentially what I'm saying is multiplying both sides by the reciprocal. Do you understand? Okay, so what's the reciprocal of 2 over 7? 7 over 2. Okay, so we know on this side we're just left with n, and I'm sorry that's jumbled. On this side, put a 1 under this fraction. On this side, who is that, baby? Before you. Okay. All right. So, what are we gonna do here? We could cross it or cancel out diagonally. We could reduce diagonally, which that would be we both numbers we reduce by 2, right? So that give me 3, -3 here and 1 here. So if we do that, that's -3. This is 1. What's -3 times 7? What's -3 times 7? -21. I couldn't hear you. You got the straw in your mouth. All right. Any questions? All right. That's all we kind of have time for. If you have other questions, please ask me tomorrow. Okay. Let's put this in our notebook and let's take out the sheet from yesterday that we did. We started working on with our group on justifying properties. I'm gonna pause for the calls. Okay. We talked about the answers to 1 and 2. I need you to turn over to the back side. I need you to think about talk about it in your group, what these properties actually mean here. What does it look like that's happening? I'm gonna give you about 3 minutes, 2 minutes to talk about that with your group. Okay, some people are still getting settled, so I'm gonna wait. I'm gonna hold off on the time. This should be in front of you. Be paused for the calls, and then I'll set the timer. People. All right, let's come back together, please. Okay. All right, so let's talk about reflexive. In your own words, table 1, what did you all think about that? What is it saying? Equal to itself. Very good. A number or term is always equal to itself. Okay, so a term or number is always equal to itself. Okay. All right. Symmetrical. What is that saying? What is that saying? Symmetrical property of equality. And there again, that we got that equality, right? Symmetrical property. Yes, Jada. Very good. Okay, that's right. So what she's essentially saying is that in an equation, both expressions are equal to each other. So even if you flip it, it's still going to be equal to each other. Okay. So both sides, that equal sign is an indication that no matter what it looks like, no matter what the expressions look like, when you see that equal sign in the middle, they are equal. So if you flip the sides or the expressions and put the one flip the expressions on either side, they're still going to be equal. Abe, are you okay? Oh, I thought you had a question. All right. So both sides of the equation are going to be equal. Even when they look different, the expressions, and you see that expression on each side of that equation, they are equal. Okay. And I'm not going to say whether it's a numerical expression or an algebraic expression because it could be both. Could be one of a numerical on one side and an algebraic on the other side. Okay. That equal sign is an indication that both of those expressions are equal. Transitive property. Okay, we got transitive property. All right. What do you think that means? Like just by looking at the example, what does that mean? Any ideas? Did y'all come up with something? Yes, baby?
It's like a term equals another term, and that term equals that term, the same, like a different term, and then the first term equals the last term.
That's perfect. Okay, perfect. So if let's just suppose if we got Bonquisha here. So if Bonquisha has the same amount of money as Shaquan, okay, Bonquisha and Shaquan have the same amount of money, okay, and then we say Bonquisha has the same amount of money as Bubba. So that means essentially because these two have the same amount of money, and then these two have the same amount of money, who else has the same amount of money? Bubba and who else? I don't even remember which name was, but Shay Shay. Bubba and Shay Shay have the same amount of money. Okay, very good. All right, so now with your group, real quickly, I'm gonna give us a minute to make sure, like 30 seconds to make sure we understand, and then after we understand, I want you to finish this up. All right, so let me give you a minute with your group to do that one. Okay, let's see what we came up with. You ready? Okay, so from this line right here, this is the original equation. Sometimes they will say it's the given. Sometimes you will see the word given, okay, because that's the given problem. Sometimes they'll write original equation. All right. So from this step to this step, what did they do to get from here to here? What did they do? Neri? They say, I didn't hear you, baby. I'm sorry. They subtracted 5 from both sides, not just one side, but from both sides. Because they subtracted 5 on both sides, what property does that illustrate? Subtraction what? Property of equality. And what other property could this illustrate? What other property could this illustrate? Up here. No, not substitution. Oh, we forgot to talk about substitution. But no, not substitution. Not transitive. Symmetric. This could also be, or the symmetric property. Both sides of this equation are equal here. This is symmetric property as well. Okay. Now, what did they do to both sides? To get from this line, the second line to the third, what did they do? Yes. They divided both sides. Okay, so what property does that illustrate? Division what? Division property of equality. Division property of equality. Again, what do we think the property that also we can say what this property is as well? What is okay? Say it one more time. I'm sorry. Reflexive property. A number is equal to itself. Okay, I can see that. Even though it's not 11 is equal to 11, but what's the other better property you think? Symmetric property. Okay, symmetric property. Reflexive is like that's your reflection. That's like if they're both sides are exactly the same. Okay, this one is more of symmetric. Okay. Now, what about the last one? What do you think that one is? That's the same thing. Let's move on. All right. See if you can do the bottom. How much time do you think you might need? 3 minutes? We'll try 3. If you need more, then I'll give you more. So here we have the original. This is the original or given, right? Okay. So what are they doing from here to here? What did they do? How did they get from this line here to this line here? What did they do? They added. What did they add to both sides? They added this 1.2 to both sides. When they added 1.2 here, that canceled this out. That's why you just left with this X. When they added 1.2 to this side, that's how you get that 3.1. What property is that? Addition what? Addition property of equality. And for those of you who don't want to write the whole thing, property, okay, of equality. Okay? All right, couple letters so we'll know what you're talking about. All right, let's look at number 2. How did we get from here, this line to this line? What do we do to get from here to here? Go ahead, baby. You divided by 5 on both sides. You divided by 5 here and got X, and divided by 5 here and got 7 and 4/10. What property is that? Division property of equality, because you're doing that on both sides, right? So we're going to write division property of equality. And sometimes they'll have the equal sign. Sometimes you might see their abbreviation as division of, equality. Sometimes you might see that. Okay? Okay. Sorry. All right. Let's look at the next one. All right. How do we get from here to here? What did they do to get from here to here? Yes, Joshua? They subtracted 3 on both sides. What property is that? Very good. Subtraction property of equality. And you can abbreviate subtraction that way if you like. Again, property of equal sign or equality. Bless you, babe. Okay. All right. So from here to here, what did they do? Abel, sorry.
They divided the two on both sides.
Okay, good job. They divided 2 on both sides. Okay. What property is that called, babe? Division property of equality. Okay. All right, let's look at the last one. How did we go from this line here, the original or given problem, to this line here? James, what did we do on both sides, babe? From here to here. Addition. We added what on both sides? The 7. What property is that, babe? Addition property of equality. Good job, sweetheart. Addition property of equality. Okay. All right, let's look at the next one. From here to here. What are they doing from here to here? Makai, please put the book up. What are we doing from here to here, baby? Dividing. What are you dividing by, sweetheart? Mm-hmm. What property is that? Very good. Division property of equality. All right. Okay. And what property is that last? Yes. That's symmetric property. Good job. Okay. Any questions? All right. So there's a sheet that I put on your table, in the center of your table. Please put that sheet in front of you. It's got a list of properties on it. This sheet we're gonna put in our notebook. All right, so a little bit out to the side here, we're gonna think of words. We're gonna describe it. So I want us to put the descriptions out here. Okay, for each one of these properties. Bless you, babe. So we're gonna put the descriptions out here beside each of the properties. We're gonna describe them. I want you to take a little bit of time with your group to talk about what you think those descriptions are. I'm gonna give you about 2 minutes or so. Just go through and see what it looks like they are doing before we actually do it as a class. Yes, baby, you need another one? Okay, thank you. Let me pause for the calls here. Okay, let's look at the first one. Commutative property. What did y'all come up with for commutative property? Table 1. What do y'all think? Okay, so with commutative, and then what are they saying? It's commutative property of what? Addition. And why do they say so? Commutative means that the order is changing, right? Addition means they're using addition to do it. So the order of the numbers or terms are changing. Okay, so the order of the numbers change. Very good, babe. Now, and this don't forget that they're also using addition. Okay. Now, what does this not work with? It will not work with subtraction. Why is it not going to work with subtraction? Because you would get a different answer. It's both sides wouldn't be equal. What's another operation that's not going to work for? It won't work for division. But will it work for multiplication? Yes. So we're going to write the same thing for this one right here, is that the order of the numbers change. And this time they're using multiplication. All right. Associative. Associative. What does it look like associative property? And they got associative property addition, so you already know they're going to be using addition. But what's the difference here? What's the difference from one side to the other? Did the order change? Is it A, B, C change? Is the order the same? A, B, C, A, B, C. The order didn't change. But what did change? The parentheses. So the grouping changed. Over here, A and B go together. Okay? They friends. They like each other. They together now. And then now over here, B is cheating on A, and now B and C go together. Do you see it? C stole her man. Loser. All right. So associative property is where the grouping changes. All she had to say was, you know what? Your breath stink and you just need a tic tac. That's all she had to say. No, what she do? She go with somebody else. That's just wrong. Just tell a person for crying out loud. All right, so the other one is also change, the grouping change. Don't forget, this one is addition. This is multiplication. So the grouping changes here. Why the other? Which ones don't work? Sorry, division and subtraction will not work with associative property either. Broke up with that person because they breath stink. The nerve. All right, distributive property. Okay, we kind of already know distributive property. How can we identify that this is distributive property? What does it look like? What's happening with distributive property? I get you every day, Neri. You jump every day. You gotta get used to that. You jump. You jump every day. All right. So what about distributive property? What how do you know by looking at it that this is distributive property? What does the word distribute mean? Why do you think they called it distributive property? What are you distributing here? The number outside of the parentheses. And how is it being distributed? Multiplication. Okay. So here, where you're multiplying a number or term to a group of numbers or terms, right? Okay. What about the additive identity property? Why do you think it's called the additive property, first of all? Because they're using addition. And what about identity? Why do you think they're saying that it's the identity property? Did the identity change? So the identity property is anytime you add zero to any term or number, does it change? No. Just a bit. The bathroom break is over now, y'all, because it's time for us to go. I'm sorry. All right. Why do you think they call it multiplicative identity? What's that about? Anytime you multiply what though? Anytime you multiply a number by one, does it change the identity? No. Okay. All right, and then we'll finish the rest of it tomorrow. Let's get ready to go so we don't go past our time. Make sure your calculator is where it's supposed to be. Hopefully my video did great today.